From ancient rituals to modern science, the desire to command the weather has been a constant in human history. Imagine a world where droughts could be extinguished with a flick of a switch, where hurricanes could be steered away from populated areas. What was once relegated to the realm of mythology is now a tangible possibility, albeit one fraught with complexities and ethical considerations. This essay delves into the multifaceted concept of weather control, exploring its history, potential, and the profound implications it holds for our future. For millennia, our ancestors could only look to the heavens in awe and trepidation, their lives and livelihoods at the mercy of the elements. They wove tales of gods and spirits who controlled the wind and rain, seeking to understand the forces that shaped their world. Today, armed with scientific knowledge and technological prowess, we stand on the cusp of turning this ancient dream into a reality. The allure of weather control is undeniable. It promises solutions to some of humanity's most pressing challenges, from mitigating the impacts of climate change to ensuring food security for a growing population. But as we venture into this uncharted territory, we must proceed with caution, carefully weighing the potential benefits against the risks and ethical dilemmas that lie ahead. Our foray into weather control began modestly, with attempts to influence localized weather phenomena. Cloud seeding, one of the earliest and most widely known techniques, involves dispersing particles of substances like silver iodide into clouds. These particles act as condensation nuclei, promoting the formation of ice crystals and, subsequently, rainfall. While cloud seeding has been employed to enhance precipitation, particularly in drought-stricken regions, its effectiveness remains a subject of scientific debate. Results have been mixed, with some studies showing modest increases in rainfall, while others have yielded inconclusive findings. The complexity of atmospheric processes makes it challenging to isolate the precise impact of seeding and to predict its long-term effects. Hail suppression is another weather modification technique that has been explored, primarily to protect crops and property from damaging hailstorms. The most common method involves launching rockets or artillery shells carrying silver iodide or other seeding agents into the storm clouds. The aim is to disrupt the formation of large hailstones by promoting the creation of numerous smaller ice particles. While hail suppression efforts have shown some promise, they are not without their challenges. The effectiveness of these methods depends on factors such as the specific characteristics of the storm, the timing and accuracy of seeding, and the prevailing atmospheric conditions. Furthermore, concerns remain about the potential environmental impacts of using chemical seeding agents, particularly their long-term effects on air and water quality. As our understanding of atmospheric science advances, so too do the possibilities for weather modification. Scientists are exploring a range of futuristic technologies that could potentially give us unprecedented control over the elements. These advancements promise to move us beyond localized interventions like cloud seeding towards more sophisticated and large-scale weather manipulation. One promising avenue of research involves the use of high-energy lasers to influence atmospheric processes. Theoretical models suggest that lasers could be used to create channels of ionized air, which could then be manipulated to trigger or redirect lightning strikes. This technology, if successfully developed, could have significant implications for lightning protection and potentially even rainfall enhancement. Geoengineering, a more controversial approach, involves large-scale interventions in the Earth's climate system to counteract the effects of climate change. Solar radiation management, for example, proposes reflecting a small percentage of sunlight back into space to reduce global temperatures. While such technologies hold the potential to mitigate some of the worst impacts of climate change, they also carry significant risks and uncertainties. The prospect of intentionally altering the Earth's climate on a global scale raises profound ethical and environmental concerns. The potential for unintended consequences, such as disruptions to regional weather patterns, ecosystems, and agricultural systems, is a major concern. Furthermore, the governance and regulation of such powerful technologies pose significant challenges requiring international cooperation and careful consideration of the potential impacts on different regions and populations. The history of weather control is not without its cautionary tales. Operation Popeye, a covert U.S. military operation conducted during the Vietnam War, stands as a stark reminder of the potential for weather modification to be used as a weapon of war. Between 1967 and 1972, the U.S. military secretly seeded clouds over Vietnam, Laos, and Cambodia, aiming to extend the monsoon season and disrupt enemy supply lines. The operation, revealed to the public in 1971, sparked international outrage and fueled fears about the potential for weather warfare. It highlighted the ethical complexities of manipulating the environment for military advantage and raised concerns about the potential for such technologies to be used for hostile purposes. The legacy of Operation Popeye continues to shape discussions about weather control today. It serves as a stark reminder that the pursuit of scientific knowledge and technological advancement must be tempered by ethical considerations and international cooperation. The lessons learned from this controversial chapter in history underscore the need for transparency, accountability, and careful consideration of the potential consequences of our actions. Imagine a world where droughts are a thing of the past, where we can prevent devastating floods and ensure a stable food supply. Weather control holds the promise of transforming agriculture, providing consistent rainfall and protecting crops from extreme weather events. It could also mean safer communities, with the ability to mitigate hurricanes and other natural disasters. The potential benefits are immense, from improving public health to boosting economies. But of course, with great power comes great responsibility. The ethical implications and potential risks must be carefully considered. As we look to the future, the possibilities are both exciting and complex. Now let's talk about the ethical and environmental concerns surrounding weather control. It's a complex issue. On one hand, the potential benefits are enormous, but on the other hand, we have to consider the unintended consequences. What happens if we disrupt natural weather patterns? Could this lead to unforeseen environmental damage? And then there's the ethical question. Do we have the right to control the weather? These are questions we must carefully consider. Moving on to the challenges in weather modification. It's not as simple as it sounds. First, the technology itself is still in its infancy. We can't precisely control the outcomes yet. Then there's the issue of international cooperation. Weather doesn't respect borders, so any modification effort needs to be a global initiative. And finally, there's the cost. Developing and deploying weather modification technologies is incredibly expensive. These challenges make it a daunting task, but not an impossible one. Let's delve into the societal impacts of weather control. Imagine a world where droughts and floods could be prevented. It sounds like a utopia, right? But we also have to consider the potential for misuse. Could weather control be weaponized? Could it lead to new forms of inequality where only wealthy nations can afford to control their weather? These are important considerations as we move forward with this technology. Finally, let's look ahead to the future of weather control. The possibilities are, well, quite exciting. Advances in technology could make weather control more precise and more affordable. We could see a future where weather-related disasters are significantly reduced, but it's crucial that we proceed with caution. We need robust regulations and international agreements to ensure that weather control is used for the benefit of all humanity. The future is bright, but it requires careful planning and ethical consideration.